The number of numbers of the form 30A0B03 which are divisible by 13 where A and B are digits is. Let's get started. In order to solve this problem, we should first find the divisibility rule of 13. But before doing it, let me explain a few conventions that we have used throughout this video. We are representing any number as 10x plus y. Even 30A0B03 is being represented as 10x plus y throughout the video. That is, we have written the units digit separately and the rest of the numbers separately. Moreover, A bar B means A divides B, and A bar B equals C means when B is divided by A, the remainder we get is C. Although this might not be the usual convention, we are using it throughout this video. Now let's get back to the divisibility rule of 13. Suppose 13 divides 10x plus y. Then 13 must divide all the multiples of 10x plus y. And why not 4 into 10x plus y? As 13 divides 40x plus 4y, and as 40x already has a multiple of 13 in it, that is 39x, even if we remove 39x from this number should still be divisible by 13. So 13 also divides x plus 4y. The most beautiful thing here is that we have reduced the initial number by almost 10 times. So no matter how large our number is, if we repeatedly do this, we will finally end up at a small multiple of 13, provided the initial number was a multiple of 13. So now we make a rule for divisibility of 13, and that is we remove the last digit of the number, multiply it by 4 and add it to the rest of the number. And if this new number is a multiple of 13, then our original number must also be a multiple of 13. Now, before applying this rule, we should note one more thing. 30 lakhs leaves a remainder of 3 upon division by 13. So, our number being divisible by 13 is equivalent to A0B06 being divisible by 13. Now, applying our rule for the first time, we get A0B0 plus 24 must be a multiple of 13. But we can reduce our job by subtracting 13 from 24 and adding just 11 to A0B0. Now, while adding 11, there are two possibilities. We might get a carryover or we might not. So, when B equals 9, we get a carryover, and when B less than 9, we don't get a carryover. Let's first check the case where we get a carryover. 13 divides A090 plus 11. That means 13 divides A101. Once again applying our rule, we get 13 divides A14. Now, once again applying our rule, we will have to add 16, but once again clearly we can add 3. So, A4 must be a multiple of 13, but none of the 2-digit multiples of 13 ends with 4. So, this also doesn't yield any solution. Let's get back to the case where there won't be any carryover. As B is less than 9, let's take B plus 1 equals C, where C is a digit. Now, our number reduces to A0C1. As 13 divides A0C1, 13 must also divide A0C plus 4. Once again, we get two cases. There might be a carryover or there might not. In cases where we'll get a carryover, the units digit becomes 0, 1, 2 or 3, depending on what C is. Similarly, in the cases where we don't get any carryover, the units digit becomes 5, 6, 7, 8 or 9, depending on what C was. Now, applying our rule, in the case where there is a carryover, we get 13 must divide A1 plus 4D. For the 4 possible values of D, we get A1 plus 0 must be a multiple of 13, and we have 91 for this case. For the second case, we get A1 plus 4, that is A5 must be a multiple of 13, and 65 is our solution here. For the third case, we get A1 plus 8, that is A9 must be a multiple of 13, and 39 is our solution here. For the fourth case, we get A1 plus 12 must be a multiple of 13. A plus 1 becomes the 10th digit, and A plus 1, 3 is our number. 13 is the solution for this case. Now let's look at all possibilities when there is no carryover. For the case of D equals 5, we get 13 divides A0 plus 20. As usual, we reduce 20 to 7 and we have 13 divides A7, and none of the 2-digit multiples of 13 ends with 7. In the second case, where D equals 6, we get 13 divides A0 plus 24, and that gives 13 divides A0 plus 11, and finally 13 divides D1, and 91 is the solution for this case. For the third case, 13 divides A0 plus 28, and this gives us 13 divides A2, and 52 is our solution. For the next case, 13 divides A0 plus 32, and this gives us 13 divides A6. 26 is our solution here. And at last, when D equals 9, we get 13 divides A0 plus 36. This reduces to 13 divides A0 plus 10, and that gives 13 divides D0, but we don't have any 2-digit multiple of 13 ending in 0. So, counting all our solutions, we have 1, 2, 3, 4, 5, 6, and 7 solutions. Thank you.